We are here talking about the hoisting system, rotating system, and circulation system. In the previous class, we ended up, I think, with the rotating system or hoisting. Which one we talked in the last lecture? Anyone remembers? Okay, so I will just, be a bit faster and talk the one which we talked in the previous one. Then I go move to it, the other one. So let's start about these systems and go back to where our lecture is. Okay, here is it. First, the first equipment of the rig is this derrick. We call it a derrick, a mast. Okay, then we call it the substructure. This is the derrick. This is the big tall structure, we call it a derrick. Then we have this one, we call it a mast. Again, it's called a derrick. Then this derrick is based on substructure. Here is the substructure. Then we say that we need the prime movers of power. Power means we need the genset. So we definitely have 3 generators there, and out of 3 generators, 2 are always operational, and one of them is on standby. For example, if one of them is not working, we stop it and we use the other one, and we do the maintenance. So it means that we do have the mechanical technicians who are very much efficient in solving the gensets problem, because we need electricity 24 hours at the rig site, and 2 of those gensets are working all the time. And as I said that in the previous one, what kind of systems that need this electricity? Definitely we need the mud pumps for circulation system. We need for the drawworks for hoisting, and rotary table for rotating. So all of them, they need the electricity. On the other side, out of these 3, definitely those people who are living there outside for their air conditions and electricity, Wi-Fi, internet, computers, all of them, they need electricity also at the same time. Then we talk about the hoisting in the last lecture. Actually, in the hoisting we said there are 7 main equipments. Okay, now the question in the test, midterm or final, the question will be, what is hoisting system? Okay, discuss the components of the hoisting system. Okay, and describe in your own words how the hoisting system works. This will be the question. You will see definitely in the test, definitely you will see this in the midterm and in the final, all of them. This is that important. So you will see this kind of question everywhere. So what is the hoisting system? Hoisting system is the system responsible for the raising and lowering of the drill string. What are the components? There are 7 main components. It has derrick, drawworks, crown block, traveling block, deadline. And the second part of the question is discuss the components. So you need to discuss what is derrick, what is drawwork. I'm not talking about you need to write 3 pages for just derrick. I'm sure you can write it if you take this literature from the books, but I don't want. All I want is simple definition. What is derrick? So simple definitions are given here. What is derrick? Derrick is a steel structure which actually hosts the drill pipes, and it take all the weights of the drill string on this derrick. It's suspended on that derrick. Then we have the drawworks. Okay, it's a winch of pulls or takes in the drilling line, just raises and lowers the drilling. So drawworks basically it has a spool and drill line in it, and it actually lowers and raises the drill string using this one. It definitely, there's a joystick of it. There's a control system which is controlled by the driller, and driller actually operates it. And if he wants to raise the drill string, he can do it from here. If he want to put more weight on it, he can release it here. Okay.
Yes,
then we have the crown.
Yes. Excuse me. Can we say that it acts like a crane? It basically lowers and up.
Yes, crane has the same system. Yes, you are right. Then we have the crown block. What is the function of crown block? It has number of pulleys in it. The purpose is the drilling line which is coming, it has to be go through it, and we have to make it straight inside. So that's why we use this one, crown block. Okay. And also you can find more clear definitions on the books and so on. Okay. Assembly of sheaves mounted on beams at the top. So these are the sheaves it has, where the drilling line is coming, and all these places and so on. Here it is. This is the ground block. Has these pulleys, and the drilling line is coming from the drawworks to here and then goes straight down. This is the one. Then we have the traveling block. Traveling block is the one which is moves up and down, and the drilling line and drill string is connected through this traveling block and back. So it's a pulley through which the drilling line is reeved and which moves up and down in the bed. This is the traveling block. Here it is the traveling block with Dynaplex hook. It looks like this one. So it's basically a hook. Upper part is with the drilling line. So drilling line, when it goes up, it can control it. And this hook has all the load of the drill string. So imagine if you have a drill string, let's say 3,000 feet. So each feet is, let's say, 20 pounds. So imagine you have how much weight it has. So it has a lot of weight actually. And all this load is suspended through this hook. So this hook, this traveling block has to be very fast. Be careful that drilling line do not cut. If it cuts, then this heavy equipment, which is very, very heavy, falls down and will cause a lot of damage. So be sure that when you use, there is no mishap happens there. Then we have the deadline anchor. I showed you the other side of the deadline anchor to control it, and the supply reed. The video of this one is already uploaded, so I discussed in the last lecture also, so you can go back and look at what are those things. This is the hoisting system. That's the last explanation. So there's a drilling line. It's a wire, steel wire. It's going through the crown block, weaves, and through the traveling block. This is the hook, and then this is. So then by operating this drawworks, we can lower or raise all the drill strength that we have here. This is the drilling. Okay. The rig equipment responsible for rotating the drill string consists of the following one. So this is the another one, rotating components. Okay. Now we are going through another system. Previous one we talked about the hoisting system. Now we are talking about the rotating system. This is another question that you will definitely see in your test. Okay, usually my exams are not really surprising. I tell you in advance what is expected, and what I expect from you that you know about these things, because these are the most important things in the drilling course. So the question will be in the test like, what is rotating system? What are the components of the rotating system? Discuss the rotating system components. So there are 6 components of the rotating system. One of them is swivel, Kelly spinner, top drive, Kelly bushing, master bushing, and rotary table. Now I will show you all of them before we move ahead about it. First of all, this swivel is connected with the traveling block. So the purpose of this swivel is to give the rotation. So for example, this is the swivel, okay, and this is its lower part. This one represents this side. This one. So it has 2 functions basically. First of all, you see there is a pipe here, hose. There is a pipe here. This gives a place for the drilling fluids to go through inside the pipe. So drilling fluid actually goes inside the drill string through this one. This is the first thing. The second thing is the above portion is connected with the traveling block and is stacked. It is not movable 360 degrees. And the lower part has the bearing, like you see here. So lower part is movable, rotatable. The upper part is static, which is connected with the traveling block to lower and raise this. And the lower part actually can provide the rotation. So, and that's why it's called swivel. Swive means rotate. So it connects. So you can see here it provides connection to the rotary hose in order to do the drilling fluid, okay, and provide passageway for the flow of drilling fluid into the drill string. This is one. So you see now this is the upper part. The upper part is the traveling block, which has you see these drilling lines here, and the lower part here is this one is the bearing here, and this is the swivel. So now drilling fluid. This is the line of the drilling fluid. This is the one here. So that's the function of swivel here. Then we have the Kelly spinner. This is the spinner, which is the bearing. We call it a Kelly spinner. So this is a bearing, and from here the drill string is moved. Drill string is moved here from here. This Kelly is actually a pipe, but it's not the round pipe, circular pipe. It's a rectangular pipe, or you can say a perfect square pipe or rectangular pipe. The purpose is so that we can do the rotation here. Here it is, the Kelly spinner. So we call it a Kelly spinner here. Okay. This is the Kelly. So I will show you the picture of Kelly. As I said, Kelly is the rectangular pipe, not the circular. This one is shows the circular one, but this one is the rectangular pipe. You can see here, it's not the circular one. The purpose, it provides the space for the drilling fluid to go inside the drill string as well as it do the rotation. That's the function of the top drive. Sometimes, uh, in fact, in the modern rigs that we have nowadays, we don't have the traveling block and we don't have the swivel. So traveling block and swivels, this is replaced by these top drives. It has a lot of benefits. It saves a lot of time. And the rotation that provides by the rotary table now is provided by the top drive. There's a motor inside it, this one here. So top drive is the replacement of Kelly, traveling block, or you can say the rotary table, carry bushing. So all of them, they are exchanged with this top drive device. And actually the purpose is to provide the rotation, and this they can use it because it saves a lot of time and connection, because as you know, one pipe is 30 feet, so this one can take 90 feet altogether and can continue drilling at one point. So this saves a lot of time in drilling. It's very popular. Then there is a device this called Kelly bushing. This Kelly bushing is actually attached on the rotary table, and the purpose is that the Kelly pipe is going inside through this one. So I will show you all of them in animation. They will make more sense. Then I will get back to them. Then we have the master bushing, from which the pipe crosses and goes down. So these are all available on the rig floor, on the rotary table, where the rotation actually is happening there. This is the rotary table. Here is the turntable. Sometimes we call it a turntable, sometimes we call it rotary table. So this is the table put on the rig floor, and here is you can see the master bushing. In the master bushing, we have the Kelly bushing here inside, and the pipe goes inside through this one, which goes down here. This one definitely rotated by the motors or electric motors through this one. So this is rotated from here, and from this the rotation is given throughout the bit. What we are doing the drilling process, drilling needs rotation, so that's the main equipment of the drilling line. Here you can see the motor, we have the shaft, we have the rotator, so this rotates. Okay, this rotates and it provides the rotation. Okay, now I will show you actually how this rotating system works. Just let me
Pick up the Kelly to the swivel stem. The Kelly has either 4 or 6 sides and passes through a 4 or 6-sided opening in the Kelly drive bushing. The Kelly drive bushing mates with the master bushing. So, when the machinery inside the rotary table rotates the master bushing, the Kelly drive bushing rotates the Kelly and attached drill string and bit. The Kelly is flat-sided with either a square or hexagonal cross-section. It's square in this drawing. It is hollow, so that drilling fluid can flow through it. The Kelly moves through a square or hexagonal opening in the Kelly drive bushing. Kelly drive bushing mates with the master bushing in the rotary table. The rotary table turns the master bushing, the Kelly drive bushing, the Kelly, and the attached drill string and bit. The Kelly can move vertically while rotating. The rotary table performs 2 functions. First, it transmits rotary motion to the master bushing, which drives the Kelly and drill string, and, with assistance from slips, hangs the drill string. The master bushing goes inside an opening in the rotary table. Small master bushings are usually a solid single piece, as shown here. Large master bushings are either split or hinged. Crew members install a 2-piece or split insert bowl in a receptacle in the center of the master bushing. The insert bowl is tapered inside and supports the back of the slips. They come in various sizes. The crew changes out the insert bowls to match with the type of slips in use. Insert bowls are also called inserts or bushings. Rotary tables have openings that range in diameter from 17 to 49 inches, 43 centimeters to about 1.2 meters. The smallest can hold a non-moving load of 250 tons, about 225 metric tons. The largest can hold a non-moving load of 800 tons, about 725 metric tons. Some small rotaries can spin as fast as 500 revolutions per minute, RPM. Large rotaries spin a bit slower, with upper ranges of about 300 RPM. Manufacturers taper the inside of the insert bowl. They taper it to match the taper of the back of the slips. The slips grip the drill string and suspend it inside the insert bowl. The insert bowl fits inside the rotary table's master bushing. Suspending the drill string in this manner allows crew members to disconnect the Kelly or top drive and break out joints of drill pipe. Crew members can remove the insert bowls to provide a larger opening through the rotary table. If necessary, they can also remove the master bushing. They may have to do this to run a large hole opener bit or large casing. Casing is pipe that the crew runs to line the walls of the hole after they drill it. A rotary table and Kelly system includes a swivel and rotary hose. The swivel has a bail, like the bail or the handle on a bucket, only much larger. The swivel bail hangs from the hook on the traveling block. The swivel allows the attached Kelly and drill string to rotate. At the same time, the rotary hose conducts drilling mud into a curved pipe called the gooseneck. The gooseneck attaches to the swivel and carries drilling fluid to the swivel via the wash pipe. The rotary hose is flexible, steel-reinforced hose that allows the swivel to move up and down within the mast. A passageway inside the swivel stem conducts the high-pressure drilling mud into the Kelly and drill string. Here is an isolated view of the swivel. The bail hangs the swivel from the hook, which is not shown. The rotary hose conducts drilling mud to the gooseneck. Mud flows through the gooseneck, down the wash pipe, and into the stem and drill string below. Wash pipe packing seals the high-pressure mud in the wash pipe as the stem rotates. The stem rotates on heavy-duty radial bearings and thrust bearings. The main thrust bearings support the entire weight of the drill string as it rotates. Swivels have dead load capacities ranging from 150 to 1,250 tons, about 135 to 1,125 metric tons. An oil reservoir lubricates the bearings and rotating parts.
Okay. Now this was a bit faster. I will explain all of the process in a much simpler and easier way with how it's works. Let's start, and I will just go back and forth according to what we saw in the PowerPoint. Well, first of all, look at this structure. There are so many things that we can talk about it. First of all, this white structure, we call it a derrick, we talked about it. Then we said we have at the top of it, we have the crown block, and from crown block, we have the drilling line. So this black sheet, if you can you see the video properly? This picture? Anyone can please tell me? Okay.
Yes.
So here you can see that we have the drilling line. Here. Now this is the upper part is the traveling block. We talked about it before. From where now, as we said that this traveling block has a hook, and then from this traveling block we have the survival here. So the first equipment for rotation is this survival, and then survival has a bearing here. We call it a Kelly spinner. Here, this one, and then from here we said survival has two functions. First, it has the Kelly spinner which rotates this Kelly. What is the Kelly? Kelly is a pipe, hexagonal pipe, rectangular pipe, or perfect square pipe, whatever. It has different types. So it's a pipe. Here you can see it's a Kelly. And then the other function of swivel is to provide the drilling fluid passage inside the drill string. So you can see there's a pipe here going on, this U shape, which is connected with this swivel. From here, the drilling fluid goes down. Okay, now this Kelly is connected inside the rotary table. Now rotary table, as I say, this is the substructure I talked about before, substructure. So derrick, substructure. So this derrick is based on this substructure. So this substructure has to carry all the weight of this derrick, all the weight of the drill string, all the weight, whatever it is. And as I said before, be sure that this drill line do not collapse. If this collapse, all of them will fall down here and will do lots of damages there. So be sure that this drilling line is properly functioning, or drawworks is properly functioning, else it will fall down. And if it falls down, then it's a big problem. Okay. So this is the Kelly. Now I will show you the rotary table. So we can.
Into the Kelly and drills Kelly system or large pin removal. The insert bowl spin as fast as they taper it to match the.
Now this is the, you can say, the drill pipe, but above is the Kelly. This drill pipe and Kelly are connected together. So now this is the rotary table. Okay, this is the rotary table. Now this rotary table is available on the rig floor. You can see here that this is the drawworks behind, the blue one, and there's a person who is operating for lowering and raising it. Okay, and now in this case, these are the slips. We will talk about slips later on, and for now, just let's talk about the rotation and rotary system right now. So this part here is this one here, and from here, this part is rotated through the
Taper of the back of the slip slope can hold the insert
here you
bowls
can
to
see
match.
that. So this is the rig floor. Okay, this is the Kelly master bushing inside it, and then it has the Kelly bushing, which is here. There's a pipe here which rotates through this one. Here you can see another one. So below one is the drill pipe, the upper one is the Kelly. Both are connected here, and the drilling continues. Here's the function of the rotary table. How
Kelly
this is the
drive
Kelly.
bushing. The Kelly.
So as I said, the Kelly is the rectangular pipe, or which is put inside this rotary table, and rotary table rotates. This turns the Kelly. Kelly turns all the
And
drill
the
pipe.
attached drill string and bit. The Kelly can move vertically while rotating.
Okay, now the question is why the Kelly is rectangular, why it is not circular? Anyone can answer me? Anyone can answer
Makes
me?
it easier or can be turn it efficiently.
Yes. Because for example, if you have the pen which is round and if you try to rotate it, it's harder. But if you have the rectangular, you can simply fit in inside it, easy to rotate. So that's why it is not even. So this rotary table is rotated by the electric motors. When this rotates, it rotates the Kelly, and when the Kelly rotates, Kelly is connected with all the drill string. So all the drill string rotates. That's the
The Kelly can move vertically while rotating. The rotary table performs two functions. First, it transmits rotary motion to the master bushing, which drives the Kelly and drill string, and, with assistance from slips, hangs the drills.
So this drill pipe is connected with the Kelly. So then this drill pipe goes down, and the Kelly is rotated there.
The master bushing goes inside an opening in the rotary table. Small master bushings are usually a solid single piece, as shown here. Large master bushings are either split or hinged. Crew members install a two-piece or split insert bowl in a receptacle in the center of the master bushing. The insert bowl is tapered inside and supports the back of the slips. They come in various sizes. The crew changes out the insert bowls to match with the type of slips in use. Insert bowls are also called inserts or bushings. Rotary tables have openings that remold a knotty M. Suspending the drill string in this manner.
So now there is two more equipments mentioned here, which we will talk later, but these are like, we call them the tongs. They connect, if you want to connect two pipes, this is the Kelly, you can see the square shape one, this is the pipe. So now they want to connect both of them. So how you screw them both together? So you need some, something that can make a connection between both of them. So, and they are heavy. So they have these kind of big ones, and they help them to connect these two pipes. Then, okay, before we connect them, this drill string, which is inside the hole, has to be suspended. So this suspension is done through the slips. So what they do, they put this switch down so that this pipe is now hanging there. Then they bring the another pipe and they make the connection. That's how the connection, make a connection works.
Members to disconnect the Kelly or large casing. Ring to rotate.
And as I said, it has the drilling fluid pipe, and this is the Kelly spinner from where
At the same time, the rotary hose conducts drilling mode. Steel string below.
here you see.
Wash pipe to the gooseneck. Mud flows through the gooseneck, down the wash pipe, and into the stem and drill string below. Wash pipe packing seals the high-pressure mud in the wash pipe as the stem rotates. The stem rotates on heavy-duty radial bearings and thrust bearings. The main thrust bearings support the entire weight of the drill string as it rotates. Swivels have dead load capacities ranging from 150 to 1,250 tons, about 135 to 1,125 metric tons. An oil reservoir lubricates the bearings and rotating parts.
Okay. So any questions from the rotating system for now? Okay, we will talk about it more in the coming this lecture and the next lecture also. So let me get back. Okay, so we were talking about the rotating system. Let me review it again, the components of rotating system directly. We said that it's responsible, this system is responsible for the rotation of drill string, and it has mainly 6 main parts: survival, Kelly spinner, top drive, or Kelly itself, bushing, master bushing, and rotary table. So this is the first part, which is the connected with the traveling block. This one purpose is to provide the way for drilling fluid as well as for the rotation. Here it is. This is the drilling fluid one. Then we need the Kelly spinner, which is helping us to rotate the Kelly from the top side. And Kelly's upper part is here, lower part is connected with the drill pipes. So upper part is connected with this one. And then we have the Kelly, which is there, which is a pipe. It's not a square. It is easy to rotate this one than the circular one. That's why we use. We said that either there are 2 systems in the modern rigs, either the hook traveling block and the Kelly, or all of them is replaced by this top drive. Then we have the Kelly bushing. Okay, Kelly bushing and master bushing, they are supposed to be there for rotation of the drill string. Then we have the rotary table. Okay, here you have the rotary table. The rotary table actually has electric motor connected to it, and it provides all the rotation at the same time. Here it is. Okay. Now after the rotating system, we have circulation system. Now purpose of circulation system is to rotate or circulate the drilling fluids. So the question in the test will come: what is circulation system? What are the components working for circulation system? Discuss the types of, discuss all the components of the circulation system. So circulation system is responsible for the movement of drilling fluids as well as solids removal from the drilling fluid. It has lots of equipment, mainly 12 different kind of equipment. It has mud pumps, manifolds, tent pipes, swivel, drill string, annulus, return line, shell shaker, descender, desilter, degasser, or mud pits. Now, these first 6 are included when we circulate it in this one. These one are after it returns at the surface, the drilling fluid. These are for the cleaning parts. It has the mud is a 24 hours closed loop system. Mud is circulated continuously. We don't inject new mud all the time. We use the same mud. What it is doing when it is coming up to the surface with the cuttings, we actually clean it and we send it back. So this is a closed system, the circulation system, and we talk about it in much detail now. First of all, in order to circulate the mud, we need a high pressure pump. So we have a very high pressure pump, and it takes all the electricity. In fact, a lot of electricity is taken by those pumps. Again, we have three pumps together. 2 of them are working, 1 of them is on standby. If 1 of them is not working, then we use the third one. Or in case there's a kick or there's high pressure coming up, then we use these kind of pumps there. Here is the pump. Then from this pump, okay, we have the manifold. Okay, these are the mud pumps mainly. Okay, then these are the small equipments of these mud pumps that are connected with this one. Okay, after the mud pump, the main equipment is the pump manifold. So the manifold actually is providing the drilling fluid. So from the mud storage tanks where the mud is stored, mud is coming through this manifold, and this pump is actually pressurizing, and from there, from this manifold through the pipe, it goes inside the survivor. So now we will go back and look at how it actually works. This is the standpipe. So you saw the mud pump, you saw the manifold, and from the manifold, you see now this is the uh, this black one. Okay, this black one is the drilling fluid line which is connected to the soil, so it goes through inside this pipe. That is what is happening. So it's actually a vertical pipe which is connected to the survivor.